Yes, dear students. Now the heading is equation of plane progressive wave. I have told you in previous videos definition of wave, frequency of wave, speed of wave, wavelength of wave. And I told you that when a wave travels, energy transferred through periodic variation of some physical quantity. People say what physical quantity there. So now I will be explaining you in case of sound wave, when wave travel, particle medium oscillate about their mean position, and hence their position keep on changing. When position changes, pressure in the medium changes, compression, reaction are produced. Due to that variation of pressure or position, sound energy travel from one place to another. Now the word is plane progressive wave. What is the meaning of plane? Why we have used the word plane? We could have written only progressive wave, equation of progressive wave. So wave travels through medium in such a way that amplitude, frequency, speed does not change from place to place. So that wave is plane progressive wave. Means whatever the amplitude here, later on the same will be here and so on. Amplitude of particles do not change. Speed does not change. So that wave is called progressive, plane wave. Plane progressive wave. Now I come to here equation of wave. So what the meaning of equation wave means? What should be the amplitude at any time at given distance, or what is the displacement particle at any time at a given distance. So for that we have to relate this y. Suppose here a longitudinal wave, Latin figure, here say okay, some source of sound wave is produced, placed at origin. I have taken this particle at origin. These are particle medium and wave traveling with speed v this way. So particle will be changing their position periodically with time and with distance also. I have taken the displacement this from position along y-axis and distance along x-axis at any time t. At any time this is a wave for the equation. This represents this displacement. This represents this displacement. Displacement taken along y-axis, distance traveled along x-axis. So now let a simple harmonic wave is traveling in positive x direction with speed v. If at any time the displacement of particle of medium is given by y is equal to a sin omega t, where a is the amplitude in maximum displacement, omega angular frequency, and is equal to 2 pi upon capital T, and t is the time period of wave. Now y, you may say here y 0. No, it is at an instant, but later it may be y may be equal to this or this. Because when wave travel, particle medium continually vibrate about their mean position. So it is at rest now, but later on at time t may have this displacement at time t. Please try to understand what I am saying. You may say that it is shown here 0. Okay, it is 0 now, but at a later time it may have some value. Okay? Now, if the speed of wave is v and there is point p, if there is a point p at distance x from origin, then what is the displacement at time t here? How much, if this wave is periodic, then time taken by wave to reach point P is x upon v. Time बराबर distance upon speed. Time equal to, it means if the wave is simple harmonic progressive wave, particle medium keep on oscillating harmonically and periodically. It means after this time t, the wave will reach here. Now, it means what is happening at point P at time t, the same thing has happened at origin at time t minus x upon v. What is happening at time t here? The same thing had happened at origin at this time. इनकी जो डिस्प्लेसमेंट अब यहाँ पॉइंट पी पर डिस्प्लेसमेंट इधर है, तो at this time it may happen here this way, same displacement particle medium. So using t minus x upon v in place of t in equation 1, we get y equal to a sine omega into t minus x upon v. Now y has become the function of time t and distance x, and tells you the displacement of particle at point P at distance x from origin at time t. Instant of time, understand, suppose now it is 11:30. So 11:30 is time t, distance I'm 2 meters away from the origin, like that. So this is the equation of a plane flexible. This is the equation of plane progressive wave traveling in positive x direction. Why it is called equation of wave? It tells the position of particle at distance x from origin at time t. Distance x may be here, anywhere else. You can find out the displacement of particles. Now, equation 2 or 1 are further in different manner also, like this. Y is equal to a sine omega t minus omega upon v into x. V multiplied or y is equal to a sine omega t minus kx, where k is equal to omega upon v. V, what is v? Speed of wave. Omega, angular frequency. Its unit will be per meter. But it is per second, it is meter per second, cancel. And k is called here wave number. Equation 3. But we know that omega equal to 2 pi upon t. Since omega equal to, this is also equation. Standard book use this equation as equation of plane progressive wave traveling in positive x direction. But omega equal to 2 pi upon t also. So equation 3 can also written as, so equation 3 can also be written as y equal to a sine omega 2 pi upon capital T into t minus x upon v, or y equal to a sine 2 pi t upon capital T minus x upon v into t. What is v? Speed of wave. T, time period of wave. T is the, so speed into time, as we know, as we know that distance traveled by wave in its time period is called wavelength, लैम्बडा v इंटू टी। मैं और पे भी कह सकता था, लेकिन मैं जान के निकाल y इक्वल टू, सो y इक्वल टू a साइन 2 पाई t अपॉन t माइनस x अपॉन लैम्बडा। दिस इज आल्सो 3, 4 lambda is the wavelength. We use this also as the equation of wave traveling in positive x direction. By v equal to देखो lambda हमने कहा v into t और v by n also, v equal to n lambda. But again I am telling the definition of wavelength is the as a distance of wave in its time period, wavelength of wave. So equation 3, 2, 3, 4 all are the different form of traveling wave in positive x direction. Now, if the wave travels in negative x direction, if the wave travels in negative x direction, then y is equal to a sine 2 pi t upon t plus x upon lambda, or y equal to a sine omega t plus kx. Remember k is equal to omega upon v. You get directly question on k using this thing. By omega 2 pi upon t भी है, 2 pi upon t into lambda, यानी 2 pi upon lambda. Oh, sorry, 2 pi upon lambda. Same thing. I have seen question directly asked on this relation. So I hope you have got my point. What is the equation of progressive wave? By in wave, particle will be oscillating periodically with distance x and time t. After every time interval, I will be telling you something more here. After every time t, there will be same value of y. For a given distance, at given distance, why I am calling it periodic wave? Because particle oscillate with time period t. At any point p, you will get same displacement after time t at distance x. Or at a given time, at this different distance, you will get same displacement after a distance lambda or 2 lambda or 3 lambda. So this is the equation of simple harmonic progressive wave. I am telling you that when wave is traveling, position of particle y is changing periodically position. So this is a physical quantity which will be changing periodically with time. People ask, what physical quantity are you talking, sir? Maybe displacement, maybe pressure of medium, maybe any other thing you will learn in electromagnetic wave. Electrical magnetic will keep on changing periodically. To the light wave, which are electromagnetic, there are also progressive wave, and the same way we can write like that. Now I come to here, I think time 19 minutes. Okay, I will take some other definitions in next video, please. You learning it here. And remember the equation y equal to a sin omega t minus kx, or y equal to a. You can take here x, here maybe z, maybe y. Thank you.